Hi, sorry. Didn't realize it was recording. All right, friends. Hey, today I want to talk to you just a little bit about surface area. And now I need you to know this is not something I need you to become an expert on, okay? So we are only going to spend just this little bit of time practicing surface area, just so you have an idea of what I even mean by that. But it's not something that I expect you to know upside down and inside out. Okay. All right. So surface area is referring to three-dimensional objects. Here's my lovely three-dimensional, whatever this is, rectangular prism. It would be the geometrical term for it. And we have learned how to find volume this year, right? We did that base times height, or length times width times height, right? Length, width, height, width, whatever. The volume tells us how much space is inside of an object. Surface area is just the outside surfaces. How much area is being taken up by the outside surfaces? So, actually, I have a better idea. Right, I'm back. Okay, it's like how much area just the surfaces take up. So if I was to wrap this entire thing in wrapping paper that didn't overlap or anything, exactly how many square inches of wrapping paper I would need. So when I'm thinking about this box, when we're talking about the surface area, this is unfortunate because there's actually still a bunch of tissues in here, but nobody's in my classroom, so it's fine. Nobody needs tissues. So when we're talking about the surface area of this box, guys, I'm making a mess. There's a whole bunch of tissues. Okay, when we're talking about the surface area of the box, I'm talking about just the cardboard surface. And you can think about it by making these lovely things that mathematicians call nets. So a net is like this. It's the surfaces all flattened out, and you're just trying to find the area of all of those surfaces. So it's pretty simple. If I'm doing this, I would find the area of this face. This is 10 by 10. That makes the area 100. The area of this face is the same as the one on the back, right? So 100 plus 100. Then I would find the area of this face. This is 1, 2, 3, 4, 5, 6 by 10. So this is 60. That means this one back here is also 60. So I've got 100, 100, 60, 60. And then I would do it for this side, which this one happens to also be 60, since this is a square, which means this is 60. So I'd have 100 plus 100 plus 60 plus 60 plus 60 plus 60. Or I could think about it as 100 times 2, because one side looks like that, the back side also looks like that. 60 times 2, 60 times 2. Add that all together, which would give me 440 square, I think these are centimeters. Sure. That would be the surface area. Okay. There is a draw it page, and there are 3 different problems where you're finding surface area, and they are giving you a net like this, where it's all flattened out. And so it's already like decomposed into its individual shapes. I am only asking you to find the surface area of one of those shapes. There's 3. You may pick which one you want to find the surface area of. Or if you want to try 2, awesome. If you want to go for all 3, go for it, right? But basically, you're just finding the area of all of the faces. This would be like a face, right, of all of those. Adding it all together, that would be how much space is on the surface or on the outside of that shape.